Hello, so today we are going to do this problem, which is part of Leetcode Daily Challenge. It's the maximum number of events that can be attended. So basically we have a list of events where we have a start day, end day, and a value, okay? And for example here, this starts at 1, ends at 2, and the value is 4. And if you attend this event, you get this value. And we get also an integer k, basically represents the maximum number of events that you can attend. So here the number of events is 2. That means you can attend at most only 2 events. Let's say k, if k was 1, then we can only attend 1. So we have to choose between these 3, right? And so the goal here, of course, also you can't attend 2 events at the same time, but also they say here that you can't attend 2 events if one ends at a day and the other one starts the same day. So what that means basically is that if we had another event that starts in day 2, like this, maybe something like this, then you can't attend this one and this one because they start on the same day, day 2. Okay, that's what this means here. Now the final goal is to return the maximum sum of values that you can receive by attending events. Okay, so overall maximum. So the first thing to think about is, well, it's really hard here to do it by just sorting, which is the usual way to do anything involving sequencing of events, because the values here can be anything, right? You could have 15 here, you could have 1 here, and then you could have 28 here. So the values of so this, for example, if this was 18, then it would have been better to take just this one, right? So it depends on the values, and the values are not necessarily in the same order as the start and end date. So that tells you sorting alone won't be enough. And if we look also at the constraint here, you can see that we have k multiplied by the number of events is up to 10 to the power of 6. Okay, so this also tells you something, because this tells you that probably we can do a solution that has as the state these two values. If it's linear in this, then it's just up to 10 to the power of 6, which means it should pass. Okay, and so how do we handle this? Well, the idea I think we can do here is that for each of these events, so basically, since it's hard to have just like sorting solve it, let's just try all possibilities. Okay, all possibilities that make sense. And so basically we can do some recursive function at I, and then at I we have only 2 choices. We can take at the element at the event at I, which basically means we can do that event, attend it, or we can skip. Okay, so we have only 2 choices, so we can try these 2 choices. However, and then go to the next one, so that would be helper I plus 1. However, we also want to keep track of how many events we did so far, so that we can check if we did k, we can stop, right? So we need some sort of count that counts that. That will pass here. Now for take, there is also one constraint to be able to take, which is that you can't take, as we said, you can't take this one. You can't take this one and this one because they are in the same day. So we need to check, and we need to pass to this function the previous day's end date, right? So we need the previous day, the previous event that we attended, we need to have its end date, right? Why? Because we want to check that the current start date, which is going to be just event at I at position 0, that's the start date, like here, the start of the event. Then we want to check if that's bigger than the previous end, right? Because if that's bigger than, why are we not doing bigger or equal? Because this here says that 2 events cannot be so that one starts and the other ends on the same day. So we are doing this so that we guarantee that they are not starting and ending on this, and the other one is ending on the same day, right? And so for this function to call it, we need to pass here the event's i's and the date, right? For the next one, because we just taken these events, right? So we need to replace previous end with for I at position 1 to get the end time, right? And now what do we gain from if we take an event? Well, we gain the value, which is just events at position, that specific event at position 2. So we do plus here. But we also want to get the max, and we don't know which solution will give us the max. So we need to sort of just take the maximum value. And so to do that, let's first initialize best to this, and then check if which one is higher, and assign that to best. Okay, so like this. And now what are the base cases for this function? So the base cases are if we reach the end of the number of events, right? Or if we did k events, because that's the max we can attend. So, or if I is equal to k, then we can stop and just return 0, so that the 0 gets added to the sum we have so far. Okay, so that's the idea. Now let's just bring this up here. But that's pretty much the gist of it, is that we will just try all possibilities for each event, either skip it or take it, and we recurse all the way to the end, looking for the best answer. Okay, and now we can here just return best, right? And then now here we just need to call, I prefer to just do n here, so let's just do that like this. And then we want to return helper at position 0 with the previous end is 0 and the count is 0 as well, right? So why am I doing previous end 0? This is because the events start date starts at 1. So that tells me that the end date would not be less than 1. Okay, and that should be it, except one other thing is that what if we are not guaranteed that the events are sorted? So what if we get this one first and then this one second? Then we will start from this one and then go try to take this one. We will not be able to. So we want to first sort by start time, so that this decision to take or not take based on comparing the end of the previous one with the start of the new one is valid, right? And so here what we need is to sort the events by just start time, and so to do that we can just sort, and that should be it. Let's see here if this looks reasonable. Looks like we need, yeah, here we need to just pass the previous end time. Okay, so it looks like there is a problem with some of the results here. So let's see. So here there is a problem because we just did an event, so we should increment the number of events. So let me just make this clear. So this is number of events, so we need to increment it. So here this is not I when the number of events reaches k. Okay, so it looks like there is another problem. So we are summing the events and taking the max of that, except yeah, so there was just a typo here. So the count, which is just the number of events, when it's equal to k, that's the base case where it's in 0. And then each time we take an event like here, we want to increment the count by 1 because we just took an event, right? And that passes. Let's see. Yep, so that passes fine. Let's submit it, except we can't submit it yet because these there is some redundancy here, so we need to cache the result because we'll end up calling the same state multiple times. So we need to cache. In Python, an easy way to do it is like this, but you can also just use a memoization map, so some sort of memo, and the keys are this index, prev, end, and count, and that should be pretty straightforward to do. So for now, let's just rely on the cache function or annotation, and see if this works. And looks like we have, so let's just make sure that it's not because of the limitation of the size of the cache. Yes. Okay, so this looks good. It passes. Now this may be a little bit expensive with the recursive function. I would recommend trying to do it with just dynamic programming array, but this solution should be good enough. Yeah. So thanks for watching and see you on the next one. Bye.